joined here with Chris Helms. We're from the Azure Customer Reliability Engineering team. And so what this means is we kind of make sure that customer workloads on Azure are reliable, customer architecting the best way. And some of the things we want to talk to you about in this session is, number one, how to architect for resiliency and for reliability and for availability, what to do when an outage does occur or when any service impacting event does occur. And then we would like to discuss a couple of events that we've had that have been top of mind for us and perhaps for you as well. So after that, over to Chris.
Thanks, Sammy. Okay, so is everybody having a good Ignite? Yeah? All right, this is a fun week. Get to do this once or twice a year, and a few of those build and Ignite, and it's always fun to get to talk to your customers and see more and more of them out there in the field. So thanks for being here. So I'm going to talk a little bit about, if it moves, there we go, customer workload reliability and resilience. And what I mean by that is that the platform obviously has a reliability and resilience goal, and so should you as a customer. You should have a workload reliability and resilience goal as well. And you weigh that every day. There's cost factors, there's lots of different factors, but we'll go through a few things that I wanted to share with you about how you can consider these elements to be more reliable and more resilient. Number one cause of outages in our industry is change, right? So that's one of those unexpected things that is sort of expected in the cloud, because what is true about the cloud? The reality is that it's always changing, right? The resources are being created, modified, deleted all the time. Automated health management services are introducing infrastructure changes where a server says, hey, I'm bad, I have a bad NIC, I have a bad disk, I have a something. Oh, I need to eject it from the platform and evacuate all the VMs or workloads that are on it. That happens without notice a lot of times. Now, we're making a lot of improvements there, but that's a change that happens in the environment without choice. Customer workloads scale and scale out around you, through you, all around the cloud, right? So those types of changes can cause network bandwidth changes. They can cause a lot of different utilization changes. We have to engineer for that. You also can see that. So sometimes it has shown its head to say, ooh, that for a moment there, things were a little bit slower than they normally are. How do we engineer for resiliency around that? Services and software updates roll out around the cloud. We're constantly rolling out updates that are happening in the various stamps and various regions of Azure around the world. Those updates need to happen. They're security updates, they're feature updates, they're bug updates, they're all the things that you expect the cloud to continue to be reliable. We just have to know that that's happening and embrace it. So we also add capacity all the time. Right? We are continuing to keep up with your demand. Thank you for using Azure and being on the cloud. We love having you there, and spin up as many VMs as you need, and hopefully we'll make more. As they say by the Doritos, we'll make more. How should customers deal with dynamic nature of the cloud? Well, you got to architect for it. You got to follow best practices. There's a lot of best practices. I apologize if there's a lot of best practices out there. There's a lot of documentation to slog through. Hopefully we'll give you some areas to look at. Obviously the ones that are listed there, availability cells, availability zones, and all of those are certain things to be looking at. Practice using these tools. So when you need them, you know how to use them, right? You know how to fail over from one data center to another. You know how to use availability zones, right? Don't just set it up and hope that it works. A lot of times it will, I hope, but hope isn't a strategy. So really test it, really do it, make your workload fail. Implement planned maintenance notifications from the Azure Service Health experience. Sammy's going to go a little bit into that a little later as far as the actual portal and where you do that, but we send out, when we know that there's going to be impact to a customer workload, like VMs where we have to reboot them to have the underlying node get patched for security or something like that, we will send notifications. If we're getting old hardware off the platform, we will send notifications to say, redeploy, and you will go to a new stamp, and then we will be able to actually retire some of the older hardware, bring in new hardware. So sign up for those notifications, use them, know where they are, please, please, please. We do try to communicate. If you don't get communicated to, it's not from our lack of trying, I promise. Sammy and I work on this with our team all the time to try and get you the best information that we can when maintenance updates might impact you. Azure Instance Metadata Service, Scheduled Events API. This is an in-VM API that 15 minutes before, this isn't days before, but 15 minutes before, an event will fire for VM type of events, where it's going to freeze or pause for a moment, it's going to actually service heal, it's going to actually reboot. So there are actual API events that you can get in those VMs that could help you if you automate a capability to absorb those events and make a decision on what to do with it. Not necessarily for every VM, for critical VMs, right? For critical workloads that you want to invest that automation in. Next slide, resiliency of the platform. As I mentioned, availability sets, availability zones. The availability zones are new, right? They're in a handful of regions. They're continuing to roll out across other regions. Definitely get on top of the availability zone, plan for that, architect that in. It absolutely is an improvement on an availability strategy. It gives you availability at a region, within a region, whereas previously you'll see the data center or the availability sets, that is actually within only a data center in a region. It's not actually within the entire region, right? So there's multiple data centers in a region. One data center resiliency when you're using availability sets. Availability zones gets you multiple data centers within the region. And of course, your data is also important, not just your workload. So the data has to get replicated somewhere, whether you're using GRS, we'll talk about ZRS, LRS. Make sure that that data is available wherever you're actually moving your workload. So on our VM platform, this is just an example. We have other SLAs and other services that leverage these technologies. A single VM has a 99.9 SLA when it's on premium storage, right? So that is a level of an SLA. If that's what your workload needs, then you certainly would be good enough to use that, right? But know that it's not the most highly available. The VM SLA for availability sets is higher, right? It's 3 nines and a 5. So that's a higher availability for availability zones, pushes it all the way to 4 nines. So that's just an example. We have different types of solutions that you can deploy. You need to be thoughtful about that. These are things that you get to choose as you're setting up your workloads. Obviously, the number of regions that we have, this slide's out of date. We just put it up here this morning. We got 54 regions now. Pop, there goes 2 more. So lots of different places where your data can be replicated to be resilient to issues. All right, for storage resiliency, these are the replication schemes. So we have LRS, which is locally redundant storage. We have ZRS, the zone redundant storage. That's where you're using availability zones, right? And so now all your data actually exists in all 3 of those zones or 2 of those zones, whichever is in that region. Again, that helps you to have a more highly available data because you can use that data in those other zones if one fails. Region 1 for geo-redundant storage, that's going to a different region, right? So now when you're moving it to a different region, now you can, for RA GRS, you can actually read that data in another region when one of the regions is down. Only one can be the master. But a new feature that is coming, and Sammy will mention this as well, is customer-controlled failover. So right now, the platform decides when we fail over storage accounts for GRS or LRS. you will have control to be able to do that as a customer. When? I don't have dates for you, but that is absolutely a platform promise. I believe it's even in private preview right now, public preview right now. So that's good. So what do we do? So that's what you do, right? Those are all things that you can set up, you can think about with your application, with your workload, and you get to make those decisions. Now, we're working hard. We have hundreds, thousands of engineers that are working on making this cloud better, to work with your workloads better, easier, more reliable, constantly trying to take out the noise, right? One of the things that we do is when we are applying updates, we have frameworks so that we're not interrupting customer workloads. Those frameworks are using geo-paired regions. So geo-paired regions is where east and west, for instance, if we're updating workloads here in the East Coast data center, is that your east? No, that's your west. Okay, so the East Coast data center, then we're not doing that same update in the west. And that is held to for almost every update. The one exception to that might be a security update, where we need to move quickly to move through the cloud. But that helps with your geo redundancy, because we're not going to make the same thing happen here that could happen here while we're making a change. So update domains, they provide the assurance that when you're using an availability set, that we're not going to take the entire fleet of VMs that you have offline, because they're in a container that has what they call update domains. So we'll only update one or two potentially if you have a whole lot of VMs that are in that update domain, or in that availability set, excuse me. But we will manage that, and that's a constraint that gives you so that we're not just going to reboot everything at once. Availability zones, again, these are also going to provide you the ability to shut off a zone, update, other zones are still active, right? That gives you that failover within the region, data and workload, and VMs, and other services as well. Continuous improvement on solutions that improve our cloud reliability. Like I said, we're constantly trying to not just improve the cloud, but also to improve your experience on the cloud. So what do? We've had several customers, just several, not thousands, just kidding, that have wanted us to have a different way of doing our planned maintenance. Some of our maintenance used to require actual reboots. We've done a lot to get away from actually having to do a reboot to apply security patches to our host OS. So our planned maintenance experience that we've launched is actually allowing you to choose the time that you want to perform that maintenance. So while we'll give you a window of 3 weeks, 2 weeks, I can't guarantee exactly how many weeks, but it will be more than a couple days usually. And you will have time to actually work it into whatever process that you have to be able to do those updates on your schedule. So that's an improvement that is, I think, very helpful in really trying to give you control. Memory preserving host updates, kernel soft reboots. This is where we're very quickly pausing your VM. I think the figure is 99% of the VMs actually are completed within 30 seconds, many of them much smaller, much less than that. A quick pause, host gets updated, does a soft reboot, brings your VM back online. Almost like it was never interrupted. So try to take the reboot out, trying to take the longer extended times out of those issues. Even in those cases, though, there will be that scheduled event that will trigger. So if you want to use the API and get that scheduled event, that will help you to maintain the availability of your workload. Live migration, introduced this year for, this actually says maintenance scenarios. So when we identify a bad node and we have automation that's out there identifying nodes that needs some sort of fix or replacement or whatever it is, we have used 50% of the time, we can move the VMs off of those nodes using live migration which will cause a small pause, but it isn't going to be a reboot service heal from one node to a different node. And so we've improved uptime and availability that way. It's leveraging the newer 2016 host OS. And that's really helping us. We're continuing to find more ways to use that as part of just general maintenance and service quality on the cloud. We're investing in platform technologies, all the machine learning. How do we identify a bad host? How do I identify this pattern? We're rolling updates out into a data center, into a region. Oh gosh, this change now looks different than the pattern used to look. How do we use that? How do we say, gosh, the number of VMs that are taking 40 seconds or 2 minutes to spin up instead of 20 seconds, right? The thresholds are changing. So now we're using those health signals to determine how quickly and when we stop releases that are in progress. So change automation, the investment that we're making in it, we have a concept that we call safe deployment framework or safe deployment program. All changes, all code that's released, config that's released, because config is code, goes through this cycle. And it starts in test and development, right? Moves on to stage once it's finished that test dev. Okay, that's pretty good. No, we want to tweak some things, goes back to test dev. Eventually makes its way out to what we have as the EUAP environment. That's the early access user program. Some people call it Canary. That's an environment where customer workloads can run, and the changes that we're making will actually be executed against those customer workloads, which gives us a better idea of how customer workloads might react to the changes we're making. So as we continue to move through, the pilot clusters are next. We have hardware pilots. We have actual, what we call first slice, where these are clusters that are largely Microsoft clusters, where we are actually owning and running services there of our own. So we're dog fooding, we're testing against ourselves, and only when we feel really confident do we start into that early regions of the rest of the cloud. So, and things have bake times where they are, right? So all of that is very orchestrated and instrumented. It's strict, it is held to and embraced as a requirement of the platform. Because you expect it, and because we need it. We need it for those critical updates. It works, and then we do broad rollout. And so we will change the velocity of the releases based on the success or some trends that look or don't look quite right. So it's not just set it, forget it, go, everybody goes home, and it's just releasing. It's constantly having signals analyzed and deciding, I should stop. Something's happening, something's not right, I need somebody to look at this. Obviously, at the bottom there, increasing cost and the impact of failures gets a lot higher as you get to that right, because we're impacting you, our customers, and that is the opposite of what we want to do in every case. So we try to, as it says, take care of it in the earlier environments, and then move only when we know and trust that it's the right thing to do. So I'm going to hand off to Sammy. He's going to talk a little bit about outage communications and the philosophies for Azure engineering.
Super. Thank you very much, Chris. When we've been kind of building out how we handle outages and how we communicate, and we've developed, we understand that our competition, when we think about kind of an outage and when customers are impacted, it's not kind of AWS or Google or other cloud providers. Our competition is on-prem. Because when you have an outage or an incident that's going on-prem, you know what's going on, you generally feel in control, like it's not pretty, and regardless of time to mitigate, the fact that you know everything, you know what's going on, you can share updates with your leadership, all of these things kind of build confidence because it's tangible and you feel it. If you have an outage in the cloud, it can feel very different. you're not sure what's going on, where do I go for updates? I looked at status.azure.com, the Azure status page, and it's green, so Azure's lying. People start tearing down their own equipment. I've heard this before. People start tearing down their own equipment, they start troubleshooting. And so all of these things, kind of, they break that trust piece. So when we think about how we're doing this, we really want to make sure that we exceed the kind of experience or the control and that feeling of when you're on-prem. And by doing this, we've kind of developed 4 key principles and key philosophies that we're working towards. The first one is speed. Right? And this is one that we're continuously working on. It has to be fast. It has to be really, really fast. So fast that we don't want human beings in there. And we're getting there. We're removing the humans from this equation, and we're making sure that we're kind of getting it right, but it has to be speed. I mentioned speed. I won't go on it. I think we understand what it is. The second one is accuracy or granularity, whatever you want to call it. But we know that customers have thousands, tens of thousands, and in some cases hundreds of thousands of virtual machines or instances in, say, West Europe. And when we tell customers, hey, there's an incident in West Europe, a subset of your VMs may be impacted. I've got 10,000. I need to know which VMs are impacted so I can take action. So it's very important that we not only tell you that, hey, stuff is going on, but we're very accurate in telling you which resources are being impacted. So these are the things. The other one is parity. Parity, I mean, for engineers, we can call it predictability, repeatability. But as maintenance goes on, as Azure and Microsoft acquires services and builds new services and new capabilities, the experience for when customers are having an issue has to be exactly the same every single time. So we have to have that repeatability built in. They should know, okay, this is what I go, this is where I go, these are the things that I can expect Azure to do, this is what I should do. And the last one, discoverability. So, and this is an interesting one. We've made great progress, but one of the things about discoverability is that we know that, like myself, you don't live in the Azure portal. You know, you live in the kind of other places. You're at swimming pools and cinemas and on holiday in parks with the kids. And if there's an outage impacting you, the last thing you want to do is, you know, open your phone and go and check the portal and kind of receive an update. And so we've kind of made progress in that area so we can deliver those last mile notifications. And we've done this wrapped in Azure Service Health. So Azure Service Health GA'd earlier this year, and it's really kind of, I don't want to say one-stop, so I won't say that, but it's the place to go to understand what's going on with your resources and what's going on with your account. So you can set up, the big thing that one of the key takeaways I would ask you is that to leverage this tool, one of the great things you can do is you can set up service health notifications. So you don't need to be in the portal to get them, and you can get all the content that's in there. You can get an email, an SMS. If you're a bigger enterprise, I would absolutely encourage taking advantage of the webhook. You can give it an endpoint. It plugs into OpsGenie, PagerDuty, ServiceNow, whatever CRM you have, anything like this. If you just give it an endpoint, it'll plug into there. And now there's native integration with logic apps and functions. Personally, I'm a logic apps guy, so whenever I'm impacted by an outage, I have a load of stuff happening and a light lights up, and I've got all this other stuff happening. But I'm big into the logic apps piece. So, but these are all native integrations. If you live in the United States, you can get a phone call, and we're previewing it at the moment. I don't think it's going to take off. I don't think people want to be called at 3 o'clock in the morning for a subset of VMs that may or may not be impacted. But you can get a phone call if you live in the US. You can receive guidance and support. And so what this means as well is that after an outage, we clean up anything. There shouldn't be any issues impacting any customers. We found that if there are customers who ever do experience residual impact, we've opened it up for every customer to be able to create a technical support case. It's nothing they have to pay for, but it goes back to our philosophy. We want to build that trust and transparency, and if Azure breaks customers and then thinks that we're kind of all in the all clear, the path to escalation should be absolutely smooth. But we hope that people don't need to use it, but it's still there. The other piece as well is we can share updates easily. We spoke to a lot of enterprises, and funnily enough, they only raised support tickets or they reached out to us because they wanted an artifact from Microsoft. Chances are, as customers, you have customers, and your customers may have customers. And so when they say, hey, what happened? And they say, if you go to the status page, scroll down, yeah, that's what happened. That was why we impacted you. Versus you have a kind of a PDF. It's an artifact you can share with your leadership. You can share with your customers. And it's something you can share within your organization as well. So if I go on to the next, I'm gonna kind of quickly go through Service Health in the portal just so it's kind of familiar. When you log into the portal, it looks smaller there on the bottom left, but it's a lot bigger. We got some big real estate when you go in there, so it's very, very difficult to miss. Once you go in there, if you click onto it, this is what it would look like if you did not have any outages. This is what we hope it looks like most of the time, if not all of the time. From there, so you can see that there aren't any issues that are impacting me in this case. If there was an issue that was impacting me, you can see there's a description of what's going on. I can understand not only the service and the region, I get my tracking ID, so I can use that to plug into my problem management system that I was talking about earlier. I can see when the latest updates were. And kind of towards the bottom, we'll zoom in on it a little bit, but we can see the potentially impacted resources in that subscription. So at the moment, I have no impacted virtual machines that are in there, so it comes back as 0. Once again, these views and filters, you may have an operations center, a NOC, a command center. There's many different ways to say it. But you can pin different views there at the moment in the portal. So when you log into your portal, you can kind of get a heads-up display of what's going on. If your team or yourself, if you think you had an issue previously, if you said you saw some kind of funny activity, you can always go into the health history. You can view the kind of incidents that were there, with start times, end times, tracking IDs, download the PDFs, all that good stuff, and kind of share what happened in that time. The other piece as well, we spoke about giving communications at a resource level. In this case, all the resources were kind of in a good state, which we saw earlier. Hopefully it was a red herring and I was being over-communicated to. But the idea that resources can go down without an outage as well. And it's very important to understand that while we may not declare that there's an outage, resources may hiccup at that time. And Resource Health is a great place to kind of understand and get those updates to say, oh, look, my VM maybe did a live, wouldn't show up in live migrate. There may be an activity that would trigger an event on my Resource Health. So it's a great place to go for that. The health alerts, this is the one thing I would ask customers to do. Because instead of looking at the Azure status page and saying that we lie, as Chris alluded to, the way that we deploy and when we make changes, we make them in such a small fashion that there's times when we will communicate to customers if it's one customer. If there's one customer subscription, we will communicate to that subscription if we know about that this is causing kind of an outage for customers. So it's not a numbers game, but we always encourage customers to get those alerts. It's absolutely important that you create these service health alerts. And again, you can pick any endpoint you like. You can pick kind of where you'd like to go with them. It's super, super simple. You click on the thing, and you choose your endpoint. And you said we have a native logic app integration. We've got functions, email, SMS, and all the good stuff. So it was a brief overview of kind of Azure Service Health. Azure Service Health is also integrated for planned maintenance events. So when you get planned maintenance events for your virtual machines, for your SQL DW, all maintenance events that happen in Azure should come through here, and you can create alerts for different things. So you can say, hey, look, I want my SQL stuff in East US to go to my SQL team. I want all maintenance for compute to go to for virtual machines to go to my virtual machines team. And you can have a lot more control around kind of the outages, maintenance, if there's any action required. So sometimes there are times where we tell customers, look, you need to do this thing. But we'll send everything that's relevant, that could cause impact to your service through Service Health. So this is kind of the key thing I would say, go and set up these Service Health alerts. I mean, people can read through this, but the idea is just to show that how we've kind of taken this philosophy, how we've evolved our communications, where once upon a time it was only on status.azure.com. We enabled activity logs in the portal. We very quickly realized that the portal isn't good enough because people don't just live inside the portal and they want the kind of the last mile notifications. And one of the announcements that we made at Ignite was the ability for customers to create alerts at a resource level. So before you could create alerts for my virtual machines in West US or whatever the case is, you can, at a resource or a resource group level, define the virtual machines that are important. If you're 10,000, you may have 5. And you can create notifications at a resource level. Not only notifications, because of the native functions and logic app integrations, you can create failover plans based on these. So if this VM goes down, you can take such and such actions using functions and logic apps. So this is something that we announced at Ignite, and it just continues to kind of make this whole experience a lot better, that I want to get an SMS or a phone call at 3 in the morning if this VM goes down, because I didn't put it in an availability set like Chris recommended. So that's kind of Service Health. The pieces or the outages or the incidents we wanted to talk about, which were top of mind for us and potentially top of mind for you, the first one was Spectre Meltdown. So Spectre Meltdown, as I'm sure you're kind of aware, that on the 3rd of January, most people in the world became aware of a CPU vulnerability that affected, I don't know how many machines on the planet. This wasn't kind of limited to a small number of machines or certain processes. This was a very this vulnerability impacted potentially everyone in the IT world. As a hyperscale provider of machines, we were very, very concerned about this. So before the 3rd of January, we'd had a lot of involvement in this. And the first piece is we were engaged at around June, July time in the previous year, 2017. We worked very closely with Google, with Amazon, with Apple, with Intel in a partnership which was fantastic because we all had the same goal to protect our shared industry. This is a shared industry, and this wasn't a one-upsmanship or anything like this. This is something we all had huge vested interest in, to make sure that our industry is safe and our customers trust the platforms that we provide. So we had a deep engagement with them, trying to understand, not only kind of understand all these potential attack vectors, what the threats are, at a cloud level as well as at a kind of server level and infrastructure level, understand all of these potential attack vectors, make sure that we can bake the right mitigations, deploy them at scale, and at the same time be very mindful that towards the middle of January, this is going to be disclosed regardless of what happens. And so we worked towards getting these mitigations done, and we had to test these thoroughly. We had to test them to make sure that when we apply these mitigations, performance doesn't drop. We don't introduce new issues. We don't get blue screens, white screens, all kind of Microsoft screens. Have to avoid all of these things on a very tight timeline. And again, this is new information. This had been existed for 25 years in the architecture of CPUs, so this was a very new problem to solve. The decision we made is that, as Chris alluded to earlier, when we did our 2012 updates to our hosts, we understood the impact was massive to customers. Customers do not like being rebooted. It's a very painful process for many, many people. And so we decided to bake this, and we had a host OS update going on around that kind of window anyway, towards kind of later 2017. We decided, listen, let's bake these together, let's roll them together so we only give customers one impactful update. We don't want to reboot customers twice. And so we decided to deploy this once with our kind of host OS update that we have going on. We worked tirelessly to bake this in so we had a planned maintenance experience. So we knew kind of customers, our performance benchmarking was fine. And now we're at a stage, so at the end of December, we opened up a planned maintenance window. It's the first time we've opened this kind of window to allow customers to choose exactly when they wanted to kind of be redeployed. And to kind of paint the picture on this as well, we'd updated a lot of our empty hosts in the background, just before this window opened. A lot of our PaaS services were already. So we're opening this window predominantly for IaaS VMs, so customers running instances of their virtual machines. We opened up this window, and customers took advantage, and they logged into their portal. They could see the VMs that needed to be rebooted. They rebooted the VMs that they wanted to. But this, towards the end of December. On the 3rd of January, the day of disclosure, we got a phone call. I'm not sure if it was a phone call, but Google communicated with us, and they said, listen, it's kind of made the news. Some of the researchers are understanding, and they're putting bits together because we're updating a lot of hosts in the background, and people are kind of looking at the hex output of some of these kind of CPU things. And they were going to disclose earlier than planned. So now we're faced with a very, very challenging scenario where we have some customers who still haven't taken advantage of this planned maintenance experience, who are still on IaaS VMs. And we have a security vulnerability that's going to be disclosed very, very early, and that could put huge risk on our customers, our platforms. And so the decision was made that we had to be very aggressive, and we had to apply these hosts in order to protect our customers from any vulnerability. And we did it at great speed. We managed to get it done, but at the cost of the experience for the customer. Because customers now who had a window, that window was suddenly cut short, and they were suddenly given aggressive reboots without really understanding what was going on. I mean, the news had made it, but the experience wasn't phenomenal at all. To this day, this has been a very painful lesson that's kind of stayed in a lot of minds for a lot of engineers at Microsoft. While we secured everybody and we got the action right, the experience was absolutely the wrong experience. Since that time, there have been 2 major security disclosures that have gone on, and we've had to do similar work to mitigate at a host OS level. And we've done so without disrupting customers' workloads. So all the work that we put in for live migration, for all these impactless things, we've taken these very painful learnings that we had to learn previously, we have incorporated them, and we're in a place where we can provide a better experience. And I just want to make clear, it doesn't mean we're out of the woods or we've solved this issue forever or for infinity, but we are absolutely continuing to make improvements as we kind of learn and we kind of receive these painful experiences. We continue to make improvements and get better. The other thing that we wanted to talk about, and this was a surprise topic for us. So we had this session planned months ago. And we had a very different outage to talk about. It was a fantastic outage. I mean, and then South Central happened. And so we couldn't really stand up here with a straight face and talk about anything other than South Central. And so we had to kind of really, understand what was going on very quickly and speak about South Central. One of the key actors in this story is our chiller plant. And I just want you to remember kind of the size and the scale of these chiller plants as it becomes more and more relevant later. So the South Central US outage, which has been top of mind for a lot of people. And I just kind of want to walk through it. So contrary to kind of what I've heard from a few customers, lightning didn't strike our data center. That's not what happened. There was in the San Antonio region, so in South Central US, we have multiple data centers. And what happened is there was a high energy electrical storm that came in. And what happened, it caused major sags and swells on our utility feed. And one of these sags was so low that it caused the chillers to go offline and cause them to lock out. And that's by design, because the chillers don't want to come up and down as power kind of keeps flapping. As the chillers went offline, the engineers responded to the alerts who were in the data center. They went outside during the storm. They got the chillers back online, and there was no customer impact. Unfortunately, 30 minutes later, the exact same thing happened at another data center within the region, and this time, the outcome was slightly different. So once again, major sag came in. It locked out our chiller plant. It lost utility power, and it locked out. At the same time, the thing that made this a little bit different is that multiple other events in the day started triggering. So generator power started spinning up in areas, although we didn't fail utility power, but generators were spinning up, and there were other events that were occurring. Engineers had about, I don't know the exact number, but in the region of 1,400 plus, I think it's only plus, 1,400 plus alerts that came in, and they kind of had to respond to these alerts, and they didn't triage accurately. So the RCA for this incident is still being finalized and published in the next, hopefully, couple of days. But what we've learned is that the engineers that were on there didn't triage the alerts correctly. And as a result, they missed responding to the chiller plant, and they were looking at other events within the data center. Critical events, but not as critical as a chiller plant. And we kind of understand where that was a very painful kind of thing for us to kind of learn. But we want to be, as I said, we want to build the transparency and the trust, and we wanted to share it. So what happened when the chiller plants happened, and just I would like to unpack this for a bit more. Of course, there's redundant cooling within a data center. It goes without saying. We have the chiller plants, and there's multiple kind of redundant cooling systems. The challenge was, or not the challenge, the thing was, is that these redundant cooling systems were not set to automatically fail over. And they weren't set to automatically fail over on purpose. And the reason was for this is because we had recently installed new equipment within our kind of cooling facility, and it has to go through commission testing. So we have to test each piece individually, and then at the end we do a final test to make sure everything works in sequence, and then we kind of flip it into automation mode. 85–90% of that testing had been completed, but the final test had not been completed. Therefore, it was set to manual mode with a statement of operations on how to react to the chiller, how to react to these alarms. It was executed perfectly in the previous data center 30 minutes before, but it failed to execute properly in this data center. So this is kind of where we were. So now the chillers are down. We have ambient cooling within our data center. Within the pipes, they offer a cooling, and they were absorbing some of the heat. And this happened for around 45 minutes. Until now, there's no kind of cooling coming in. The temperature's rising. For about 45 minutes, this could be sustained. After the 45-minute mark, the temperature begins to kind of increase rapidly to a point where hardware begins to shut down to protect the integrity of itself, as designed. This is what it's supposed to do. It's supposed to shut down because it's getting too warm. It got so warm that the air handlers shut down because the data center thought there was a fire. So what is the thing when there's a fire? Starve the room of any oxygen. So there's outside air coming in. Let's shut that down. Let's starve the fire of any oxygen. Let's call the emergency services as well, and all these kind of automated things happen. So now we're dealing with a situation where staff have been evacuated from the data center. We have to protect lives. The temperature now is increasing at a higher rate than it usually would. And the hardware shutdown didn't occur as rapidly as it should have in some areas, and we received damage to storage, a critical part of storage and some of our networking infrastructure in that area. So what happened then, we got back into the data center. Of course, we have more than double the amount of chillers that we run on less than half the number of chillers that we need, but during the time when we were evacuated, we kind of understood now what was going on. The picture was a little bit clearer. We kind of manually reset all these chillers because they were in lockout mode, had to kind of clear all these alarms and errors and cache and restart all these chillers, and we started every chiller that we had to bring cool air into the data center, open air handlers to get kind of air coming in. We did everything we could to bring the temperature down. Once the temperature is down, we have to start kind of looking at where we are. And from the time it took of when we got locked out to the time it took to get kind of the data center cool and stable and in a place where we could start launching things was 3 hours and 29 minutes. It was a lifetime for a lot of people, those 3 hours and 29 minutes, and it's still 3 hours and 29 minutes too long, and it shouldn't have happened. But as I said, we want to build trust and transparency. We take this thing very seriously, and we just kind of wanted to let people know this is what it took from when we got locked out to when we got things back online. The biggest damage done to our infrastructure was storage. And the storage was, there was physical damage there, and recovering storage was without a doubt one of the most challenging things, and this is why it took so long. Just to kind of, so everyone in the room is aware of kind of the Microsoft stance on things. Microsoft Azure, will always recover data when it's possible. The only time we will fail out storage is if the data center sinks into the ground and then is buried, and then that's buried on top of it as well. And there is no chance that we can do anything, we will fail out. If we can recover the data, we will always recover the data. Always. So what did we do? We tried recovering the data. And we managed to we had to take out the disk, we had to check for integrity, migrate data across, and validate that everything was kind of integral, and we didn't lose any data, and we didn't lose any customer data. And we kind of had to go through that process. We expected that there would be impact to South Central US. We knew that there are services running there, and we expected it. What we unearthed and what we didn't expect was impact outside of South Central US. And I just want to kind of go through these, I know I'm short on time, relatively quickly. The first one, and we should kind of be mindful of this, was ASM. ASM is Azure Service Manager. And this is a service that uses service management operations for classic resources, for V1 kind of resources, but this is the Azure Service Manager. And this went down. And I'm going to kind of reference this later. A lot of customers know that VSTS was impacted as well. For those people who are kind of heavy VSTS users or interested in VSTS, I would absolutely recommend you read Buck Hodges. Buck Hodges leads our DevOps team. It's been rebranded. The DevOps team, he wrote a blog, he wrote his RCA. I won't do any justice to Buck by kind of regurgitating it, so I would absolutely recommend you read Buck's RCA on that, and I think he did a fantastic job covering the VSTS impact. The other major impact to customers was AAD. And it took us a while to fully understand what happened with AAD, but we'd like to share it with you. So AAD, when the South Central incident happened, AAD did what it was supposed to do, and it failed out of the region. And so it's kind of running, it's got sites that failed out of the region, and it's authenticating traffic, and it's doing this for about an hour and a half with no problems. The East Coast suddenly comes online, or suddenly, gradually, and you've got New York, Washington, you've got big cities, a lot of authentication traffic that's suddenly kind of picking up, and the authentication requests go up. As they go up, what should happen, as we all know, autoscale kicks in. And autoscale will just kind of allow it to kind of scale out, deal with these requests without any issues. And that's what happens. The autoscale for AAD running in that region had a dependency on ASM, which was impacted because of this. So it couldn't scale out. As we kind of hit the peak of what happened, our mechanisms do what they do. They throttle the service because they don't want to tip the service over. So we began throttling our own requests because we're hitting kind of peak things. The last thing that kind of exacerbated this is we unearthed a bug in our Office clients. This bug, and we've never faced this situation before, so it was news to everybody. But in these Office clients, there was a bug which had a very aggressive retry logic and no backoff logic. So this compounded our situation even further and kind of made things very, very challenging for AAD. One of the things I know Chris alluded to it, is that, and I know I'm very short on time, so apologies. One of the things that we did, we've taken a lot of remediation steps, and the RCA will be published, and people can read that content there. One of the big kind of things that we've announced at Ignite is the ability for customers to be able to fail over their storage accounts at an account level. This means you don't have to wait for Azure to recover data, because you know our policy, we're always going to recover data. But if you're okay with a small kind of delta because of the nature of asynchronous replication, you're okay with saying, I can lose a little bit of time, I just need to get back online, this will be good news for people who want to leverage that feature. I don't know when it's going to GA, but I know that it's been announced at Ignite as part of our thing. So we've spoken about the service impact of user dependencies. I'm getting kind of watch tapped by my team as well, and I know I've run over, so I'm very sorry. I do want to say, look, we did kind of cover how to architect for availability and resiliency. We've covered Service Health. We wanted to share kind of 2 very impactful events. We really want to come back next year and kind of talk to you about goodness that we're doing. Hopefully, not dramatic events like this, because we would have, it wouldn't be so impactful. But look, thank you very much for taking the time. Please do give us an evaluation, and thank you very much. Thanks.